Hi everyone. So I hope you're doing well and that you're getting what we've covered so far. Remember that if you need extra help, there is tutoring Mondays and Thursdays. Mondays is in Mr. Nelson's room, so that's right beside my room. And then Thursdays is in Miss Rhodes' room, so just down the hall. You can also get help in ACT Lab from the Math Lab in Miss Rhodes' room. Stay after with any teachers that teach that subject. Also be checking with Miss Bowles if you want to check your homework. She should have those keys for you, just like I did before. So if you're not sure if you have something right, wanting to check, please check with her, okay? So this is the last lesson for this unit. Unit 2 is really short, so you'll have a test coming soon, okay? So make sure you'll just have these 3 homeworks. Make sure those are going to be ready to be turned in, because that deadline is quickly approaching, okay? So now you still have time to get help, but you won't later. So today we're looking at symmetry, and I know you've heard of this before. If you fold the paper and it matches up kind of like in elementary school, then it's symmetric, but that is kind of the first form. We're going to look at 3 forms today, okay? So first one we're going to look at here is line symmetry, okay? So that is kind of the typical one you've heard of. So I'm going to say if you were to fold the shape, so think like fold, it would match up to itself. Okay, so again, that's like the one that you're most familiar with, probably, is just the line of symmetry, okay? All right, I'm actually going to skip to rotational first over here and then come back to point. So rotational is if you turn your shape less than 360 degrees, so emphasize here, rotation is a turn still, so it has to be a turn for that. So if you turn it, put less like that, less than 360 degrees, the shape would match up to itself. Okay. So now jumping back to point, sorry, lost my train of thought there for a second. So rotational is if you're turning it, it can have more than one location of rotational symmetry along with the same for the line, okay? And then if we're looking at point, okay, point is only one. It's not going to have like multiple locations. It is if you rotate the shape 180 degrees. You can also think just if you turn it upside down, okay? So 180 is upside down. And it matches up to itself, or is the same. Okay? So now we're going to kind of look at how those look on a shape and recognize those. So looking at our first one here, so we have a 1, 2, 3, 4, 5, 6, a hexagon, all right? So first we're going to kind of just go down the line and see if each of these are true. So line symmetry, meaning if you folded that shape, would it match up to itself? And here you want to think about your line of symmetry. You're going to see this drawn fairly often. It's like a dashed line, okay? So one way I could fold it to make it match up to itself would be right down the middle, okay? So there's one line of symmetry. So I know at least has it, so I'm going to put a check mark there. It has at least one. Okay, then I could do through these corners. And I could go through this part. So that's 1, 2, 3. Then I could go, let's see, through here. This one has a lot, so it's hard to pick them all out. It's usually 4 then. Okay. I could go through here. About 5. And I could go through these corners. So 6. Okay, I'm not going to count these over here like again because that's the same line. Okay, so I kind of see where they start over. Okay, get to this middle one down here. Well, that's already up here with our 1. Okay, so that has 1, 2, 3, 4, 5, 6 locations where it has a line of symmetry. Okay, I usually look at rotational before I look at point because if it does not have rotational symmetry, it can't have point either. So I usually look at that first. So here you're thinking if you were to rotate or turn your shape. Okay, so if I took this shape and I spun it around, how many locations could I take that? And so basically if I pulled this point and I pulled it over to here, okay, well, all these others would still match up because this is just a regular hexagon. The sides are equivalent or congruent, okay? So I could go to here. Well, there's one rotation where it would be symmetric. Then I could go to here. So that's 2, 3, 4, 5, and then back to where we were, 6. Okay, so that's how many turns or how many spins and where it matched up at each spot. So I'm going to check that one. It does have it. And there were 6 there. Okay, and then point, remember, is if you turn it 180 degrees or upside down. So if I turn this, do a different color here. So again, if I take this point and I go 180 degrees, that would put me right here. Okay, that would match up. Those are going to be symmetric still. So I want to check point as well. Obviously, I won't check none because it had these others. Okay, so on to number 2. So I want you to take a minute here, pause the video, and see if you can solve 2. Okay, hopefully you paused, and hopefully you also found that the triangle has no symmetry. So you can't draw a line to make it match up. You can't rotate it correctly. Point symmetry, so think here, maybe some people would think that one might be confusing. If you rotate this 180 degrees or flip it upside down, it's going to look like that. Okay, well, it's not symmetric, it's not matching up to be the same. Is it still congruent? Yes, but it's not symmetric. Okay, reset there. All right, 3. So we have a parallelogram here. So start off line. So basically, could I draw, and don't write this, I'm just going to draw it to show you. If I drew a line of symmetry there, well, these don't match up. Okay, so that doesn't work. If I did it this way, they are also not matching up. So this one does not have a line of symmetry. It's not. So we're not going to put anything on that one. All right, now we want to check rotational. So if I took this and I rotate it to here, okay? So that's going to make my shape look kind of like that-ish, okay? So that first turn, that first 90-degree turn there would not be symmetric, okay? So I can't count that one. But if I turned it then again, all right, that would flip this over into here, and it would match up there at that 180 degree point. All right, and then while I turned it again, it'd be down here, and then it would be back to its original. So I would count that middle 180 degree turn and that final turn of where it ends up back at itself. Okay, so that will give us 2 rotational points of symmetry. All right, I'm gonna erase that a bit. And again, so if it's rotational, it will you typically have point as well. So if I turned it 180 degrees or upside down, it would match up, so it would have point symmetry. Oops. Okay. All right, 4th, the star. So let's go ahead and pause here, see if you guys can solve number 4. Okay, if you paused, hopefully you got the answers. There's quite a few on this one, so let's start and look at lines. So I could draw the line of symmetry right down the middle. Okay, so there's 1. I could cut it in half this way. So there's 2. Could do it this way. So there's 3. That way is 4. And through here would be 5. Okay, again, I'm not going to start counting this one and this one and this one because those are the same as this line, the 1, 2, and 3. Okay, so I don't count them again. So I had 5 lines of symmetry, so that's 5 points there. All right, remember, let's look at rotational next. So if I took my star up at the top and I turned it, okay? If I first turned it here, that would be 1 first rotational turn. And there, so it would be symmetric because I'm just taking this if I spun it around, okay? And you're really turning from the middle point is what you want to think if you're turning it that way from this middle. So that's 1, 2, you could spin it to here for 3, here for 4, and here for 5. So 5 points of rotational symmetry. And then lastly, see if it has point symmetry. So remember, this is where you turn it 180 degrees. So that means if I took this point and I drug it all the way down to here, well, then your star is upside down. It's going to look, okay, I'm going to try this. Try to draw this upside down. It's going to look somewhat like that, okay, with your point being up here instead of it going in here. So that's not going to match up. It will not have point symmetry, okay? Okay, so on to our next part here. Looking at the pre-image versus the image. So pre-image is just your original, okay? What did your image start off looking like? And then the image is what happens afterwards. And what I want to break down here is kind of looking at the next page. So if you were given kind of the mapping rule, which is this, okay, like we did last time. If you're given that, how can you tell what transformations have happened? So remember, I have 4 types of transformations. There's a translation, rotation, reflection, or dilation. All right. So what you need to focus on is look at the mapping rule. So remember, this is the mapping rule. I'm going to write that down here in case you need. So look at the mapping rule to tell what transformations happened. Okay. And then, so there's 4 types. Translation, okay, this one is going to have addition or subtraction in the mapping rule. I'll give you an example on each of these. So, such as, maybe it will say x plus 2, so that means your x's are moving to the right 2 spaces, and y minus 1, so your whole shape is moving down 1, okay? So that's what it would look like if there was a translation that had happened. Okay, rotation. This is going to either have x and y will be flipped, or they will both be negative. And you can definitely look back on your notes for these and look at the mapping rule part to kind of remember what that looks like in the rule. So what that looks like when we plug it into this, okay? So x and y will be flipped, like switching locations, like y would come first is what I mean by that, or both will be negative. So that might look something like y plus 1 comma x minus 7. Okay, so here y is first, x is last. That tells us the rotation part, and then the plus 1 and minus 7 tell us there was also a translation that happened. Okay, so there's going to be more than one thing happening. All right, reflection. This has 2 options. If it's over x, then y will be negative. So it's going to look maybe like 2x comma negative y plus 2. So that negative right there is what would tell me that that was a reflection over x. If it was over y, then x will be negative. Okay, so maybe negative x plus 3 and 3x. So the negative with the x tells me it was a reflection over y, plus 3 tells us it also went up 3 as a translation. All right, and lastly, dilation. So remember, dilation is the one that changes the actual size of the shape. So it is always dealing with multiplication. So x and x, I'm going to put and or y. So it might only be one of them, might be both of them. So x and or y will be multiplied. And remember, the number that you're multiplying by is the scale factor. So maybe it says 2x plus 1. So that means they doubled it there. They times it by 2. And they also moved it up 1. And maybe it also says 1/2 y minus 7. Okay. So this part tells us dilation because x and y are being multiplied by a number. All right, so now we're going to look at how we use that down here. So find the coordinates of the new image if the original points are A, 4, -2, B, 6, 3, and C, 8, -1. And the new image is found by following the rule xy transformed to 3x plus 2 and -y plus 8. So that's our mapping rule, remember. Okay, so we have our original here, or our pre-image, or looking for the new coordinates for the A prime, B prime, C prime. So this is like we did kind of before. So what I'm going to do here is just plug in. So I'm going to write this here beside. Do it one point at a time, and be careful to stay organized on this because that can get a little tricky. So we have what is being done here. Now I just need to plug in my x and my y to see what that gives me for my new coordinate, okay? Because I'm not going to leave it like this. That doesn't tell me much. So for the x, and I set mine up as an ordered pair just so I don't forget what goes where. So I'm going to do 3 times 4 because that's my x value, plus 2, comma, then my y will be negative y. Well, y is negative 2, so we're going to have to change that around a bit, okay? And plus 8. So this is the x section, this is the y. All right, so just so I keep those straight. Okay, so 3 times 4 is 12, plus 2 gives me 14. Here, negative 2 makes that positive 2, plus 8 gives me 10. So my new coordinate is A prime will be 14, comma 10. So write that here. Okay, why don't you go ahead and pause the video and try to plug in B and C to get those. Okay, hopefully you have paused and plugged in. So for B, you should have plugged in, so 3 times 6 plus 2. All right, well, that's going to give you 20. And then for Y, it's negative 3 plus 8. Well, that gives you 5. So B prime is 20, comma 5. All right, and then for C, plugging in 3 times 8 plus 2, comma, negative 1 plus 8. Be really careful when there's a negative here and you're plugging in a negative. Make sure we change those to be positive inside. Okay, so that's 24 plus 2. So I have 26 for my x, and 1 plus 8, 9 for my y. So 26, comma 9 for C prime. All right, now the part that I kind of showed you up here. So what type of transformations took place? So we're looking right at this, okay? So first thing I noticed kind of right away is we have the plus 2 and the plus 8. Well, that tells us it's a translation because it's adding. So translation. I'm going to put in parentheses what showed me that as well. So plus 2 and plus 8. All right, but that's not the only thing that happened. I also have I have a negative with my y. So I'm going to look up here. All right, well, reflection over x tells me that y will be negative. All right, so that's what happened there. So reflection over x, and I knew that because there was a negative y. Okay, and then lastly, there's some multiplication going on here with the 3x. So if there's multiplying with either your x or your y, that is a dilation. And I knew that because it said 3x, so 3 times x. All right, moving on to 6 here. Find the coordinates of the new image if the original points are a, negative 1, 3. So again, I'm going to look at my rule here and plug in. These do have fractions, so if you need your calculator, please utilize that. Do not get it wrong because you didn't use a calculator. All right, so I'm going to start off here. So A, plug in, that's 2/3 times x. A's x value is negative 1. Right, so multiply there. All right, so that's going to be my x. So 2/3 times negative 1 is negative 2/3 minus 1 gives me, well, here, I'll write it a little slower. All right, so negative 2/3 minus 1, that's like plus and negative. Again, you can use your calculator though. So that comes to negative 1 2/3 for the x value. And for the y value, it's just 4 times y. So that's going to be 4 times the current y value is 3. All right, so 4 times 3 we know is 12. All right, so my first A prime is negative 1 2/3, comma 12. Okay, again, go ahead and pause and try to do B and C on your own. Okay, if you pause, you'll be checking now. So B, I want to plug in 2/3 times negative 5 minus 1, and 4 times 2. Yeah. Okay, so that's a 3, sorry. So 2/3 times negative 5 is negative 4 1/3. Oh, minus 1, sorry, I did that part as well. Okay, and then 4 times 2, 8. Okay, and then for C, so I'm plugging in 2/3 times 0 minus 1. So that's going to be 0 minus 1, which is negative 1. And then I'm going to do 4 times 7, which is 28. So my C prime is negative 1, 28. All right, again, looking at the types of transformations that we have. So I always kind of just go down the line and think, all right, is there a translation? So what on here tells me translation? Well, negative 1 does. Minus 1 moved it down 1. So translation, minus 1 told me that. Okay, now is there a rotation? So X and Y would be flipped, or they would both X and Y would be negative. Well, that's not happening there, so no rotation. All right, reflection. Either X or Y would have a negative in front of it. They don't, so none of that. And then lastly, dilation. So is X or Y being multiplied by something? And we do have a 2/3 with our X and a 4 with our Y. So that tells us a dilation happened. All right, 7 and 8 are a little bit different because they give you the new points and they want you to find the original. So I'll kind of show you first how to do this and let you try it out. It's essentially just an equation, so that's good if you're good with equations. So I'm going to take, let's see, so, and you have to do it one at a time, so this is kind of a slow process, all right? So for my X, I have to go one at a time here. So for A, and then for my X value, all right? It is, actually I'm going to erase that. Okay, so I'm going to take the X portion of the mapping diagram, or mapping rule. So this side's X, this side's Y. So what they did to get this point, this is the new one. So up here, what we did, like up here, was we plugged in the current one to get the new. So now we have the new one, but we don't know what they plugged in. We're looking for what they plugged in. So what we can do is write an equation. So I'd use this side, negative 1/4 X plus 2 equals the answer they got. Well, they got negative 2 for X because that's in the X spot. So I write it like that, and then I just solve this. Okay, so I would minus 2, so that's negative 1/4 X equals negative 4. To get rid of a fraction, I multiply by the reciprocal, keep the negative, and then 1/4, the reciprocal is 4/1, or just negative 4. These cancel because they equal 1, and I multiply by negative 4/1 on this side. Negative 4 times negative 4 gives us positive 16. For X, I would write that in now so you don't forget it. So 16 there. All right, now I find the Y. Okay, so I'm going to set up the same side, but for Y. All right, so, or the same style, but this side. 3Y minus 7 equals, well, they got 5 for Y. So add 7 3y equals 12, y equals 4 if I divide. Squeeze that in because I was running out of room. But so you get 16 comma 4. All right. So why don't you guys go ahead and pause, try to do B or C, all right? One or the other, or both if you have time. Okay, so for B, if I set this up, I'm going to do negative 1/4 x plus 2 equals, their x value was 5, minus 2, negative 1/4 x equals 3, again multiplied by the reciprocal, which is negative 4/1, or just negative 4. Same thing over here, x equals negative 12. All right, same thing with y, but I'm using the other side. So 3y minus 7 equals 7. Okay, add 7. 3y equals 14. Divide by 3. Okay, and that gives you y equals 4 2/3. Remember, try to leave two fractions with the denominator of 3 as a fraction since it's a non-terminating decimal. Okay, and C, so negative 1/4 x plus 2 equals 8, minus 2, negative 1/4 x equals 6 times by the reciprocal. I'm doing this quick since you should have already done it, and x equals negative 24. Remember, write it in as you get it so you don't forget. For the y, 3y minus 7 equals negative 9. Add 7. 3y equals negative 2. Divide by 3. Y equals negative 2/3. Okay, and what type of transformations took place? So again, I usually look for translations first. So is there addition or subtraction? Yes, there's a plus 2 and a minus 7. So that tells us there is a translation. And write in parentheses how you knew that. Well, they added 2 and then minus 7, so it went to the right 2 and down 7. Okay, next look for rotation. So are x and y flipped? No, they're in the right location. Or are they both negative? No, they're not both negative. So no rotations. Then check reflection. So do x or y have a negative? Y doesn't, but x does have a negative. So if x has a negative, that means it's a reflection over y. Oops. With our negative 1/4 x. Okay. And I ran out of room here, so move it over. But lastly, there is a dilation because there's 1/4 and times 3. Okay, and I'm going to take a quick pause because London is crying, so I will be back in just a minute to finish 8. Okay, so now to finish off with number 8. This is going to be the same way that we did 7. So you'll set up the equation with the x side of the mapping rule set equal that, set equal to each x value, and then the y side set equal to each y value. Okay, I want you to actually take a minute here and try to set up the first equation for A on your own, and then I'll give you the equation to have you check it. Okay, so pause, set up the equation. Okay, so equations for A, point A. You should have, so we're given A prime, we need to find the pre-image, all right? So I would say negative 1/2 x minus 5 equals negative 1. So that's the equation you should have gotten. All right, when you solve that out, we add 5, negative 1/2 x equals 4. To get rid of that negative 1/2, I multiplied by the reciprocal, which is negative 2. and x equals -8. Plug it in now so I don't forget. All right, for y, you should have -y plus 5 equals, for a, the y value was 3. So I would -5, that's -y equals -2. Y is not by itself if it has a negative, so I divide both of those by -1 to give me y equals +2. Okay, go ahead and pause the video to complete the equations and find the original coordinates for B and C. Okay, if you have paused, now I should be checking over. So B, we have -1/2 x minus 5 equals -8. Add 5, -1/2 x equals -3 times -2, x equals 6. All right, for y, -y plus 5 equals 0. Subtract 5, -y equals -5. Get rid of the negatives, y equals +5. All right, for C, -1/2 x minus 5 equals the x value 0. Add 5. -1/2 x equals 5 times reciprocal, -2. X equals -10. And lastly, y plus 5 equals -3 minus 5. Y equals -8. Okay, divide each by -1. Y equals 8. Okay, and then what types of transformations took place? Go ahead and pause here and see if you can get those transformations. I forgot to pause on the previous one to see if you could pick those out. But pause and see if you can look in your mapping rule here to see what happened. So be sure to tell how you knew it as well. All right, if you are checking, so look first, is there a translation? Yes, because it's -5 and +5. So write in parentheses how you knew that. -5 and +5. Okay, is there a rotation? So are x and y flipped? Well, they're not flipped. Or are x and y both negative? And that did happen. So there's a negative in front of the x and a negative in front of the y. So here, just to differentiate from dilation, dilation is only going to be multiplying by a positive number. It's not that negative, it tells us something else, okay? So I also have to know what type of rotation, okay? So since that was a double negative, you might need to look back at your notes for rotations and see how, like, what does what on that. Look at the mapping rules that we wrote down there. So when they are both negative, that's a 180-degree rotation. And I would just write -x and -y. Okay, and reflection, so in that case, one of them would be negative, but not both. So we know they both did here, so that's a rotation. And then dilation, is x or y being multiplied? Well, yes, x has a 1/2 on it. Y is not, but so it's a dilation because I have that 1/2 x. Remember, the negative part applies to the rotation, not the dilation. All right, and that is all for today. Remember, a test is coming up soon. All 3 homeworks will be due. The same rule applies as if I were there, as in terms of you cannot turn in homework past the date of the test. I have had some parent emails about that, so if your parents ask about your missing work and things, it has to be in by the test or it's not accepted. That's always gives you quite a bit of time, okay? But feel free to email with any questions or go find someone in the math department who will definitely be willing to help you, okay? And check your homework with Miss Bowles. All right, have a good day.